All right, so Unit 12 test review. Going to start by putting this function into the calculator. So I've entered that into y equals. Going to the graph, I'm going to get a sense of what this looks like. Okay, so it's going something like this, going down and back up. I'm just doing that to kind of get a good idea of what's happening. I'm then going to label my maxes and my mins along the way. So remember to do that. We do second, trace, and I want this one right here. That's a maximum, so I'm going to choose 4. Left bound, well, it looks like -1 is to the left of that, so I'm going to choose -1. And then it looks like 1 is to the right of it, so I'm going to choose 1. And it looks like it's in between those two arrows, so I'm going to hit guess. So that is the point, 0.1, comma, 2.1. So that's that point right there. Okay. Then I'm going to choose this point here. That right there is a relative minimum. So I'm going to do second trace 3. And it looks like 1 is to the left of it. And I can't tell where 2 is, so I'm just going to choose 3 to be safe. Okay, but that point is definitely in between those arrows. Hit enter. And that tells me that that point is 1.6, -1.01. I never put just -1 if there's any decimal at all because I don't want it to be misleading, okay? So now that I have all of my points in there, I'm actually done with my calculator. As long as I go through and label my maxes and mins, increasing means that as you're moving to the right, or as x is getting larger, your function value is getting larger. So in other words, this is where you're climbing uphill from left to right. So it looks like to me this whole piece right here, we're climbing uphill. So that is from -infinity up until this point right here. So we are increasing from -infinity until x equals 0.1. And I'm using parentheses here just because we're neither increasing nor decreasing at our highest point. Okay, then from here to here, it looks like we're going downhill. Okay, decreasing is downhill from left to right. So from here to here, we're decreasing. That x value is 0.1 until 1.6. And then from then on, we're going back uphill, or we're increasing again. So from 1.6 forever, or to positive infinity, we are increasing. So we have labeled all of our increasing and decreasing there. Okay, zoom in so you can see that. All right, relative maximum. Remember, your relative maximum is a high point, but not the highest point. So here, this peak is a relative maximum. So that's the point, 0.1, 2.1. There you go. An absolute maximum, that means the highest point. This one right here, this is not the highest point because there's something else higher than it. But since it's going to keep going on to to positive infinity, we are not going to have a highest point here, right? Infinity, you're never going to actually reach it. Relative minimum, that's where you have a valley, okay? Okay, so make sure this is still rolling. Yes. Relative minimum is anytime you have a valley. So this point here, that's a positive 1.6, and a negative 1.01 would be your minimum. Absolute minimum is the lowest point. Well, we're never going to get to a lowest point because it's going to negative infinity, so that doesn't exist. Remember that our domain for polynomial functions is always all real numbers. Okay, I'll tell you how to write that in interval notation. Range, remember that's asking how far down does it go, how far up does it go. Well, it's going to go down to negative infinity. It's going to go up to positive infinity. So our range is also all real numbers. Left in behavior. So as x is going toward negative infinity, aka we're going to the left, as we're going to the left, what's happening to the y value? Well, as we move further and further left, that's going toward negative infinity. So this would be f of x approaches negative infinity. Okay? Right in behavior. So as you're going to the right, What's happening as we move to the right on this function? Well, this is going higher and higher and higher, so the function value is going to a positive infinity. Number of possible zeros. Number of possible zeros always matches your degree. Your degree is the highest exponent. So our possible number of zeros here is 3 of them. To find the actual, we could use long division or any of that, but in this table, I'm okay with you finding them in your calculator. So our zeros, to do that, second trace 2 for zeros, left bound. So again, if I'm trying to find this one over here, it's about right here. So I'm going to choose -1. -1 is definitely to the left, and 0 is definitely to the right. So notice that I'm looking at this point right here. -1 is to the left, 0 is to the right. Enter to guess. We have a 0 at x equals -0.5. Okay, let's try another one here. That looks like it's at 1 and looks like it's at 2. So remember, we can always double check that in our table. Oh yeah, look, there's one at 1, there's one at 2. So I don't even have to do the other function thing. So 1, 2. And I know I've found them all because I should have a maximum of 3 zeros. Let's move on to the next one. Okay, I'm going to begin by putting this into my calculator. -x squared plus 4x plus 5. I'm going to go get a good sense of what this is looking like. Okay, so here I go. Let me graph it real quick. Okay, so I'm going to go find that maximum point. Second trace maximum. 0 is good. I don't know, 1, 2, 3, 4, 5 is good. Right, it's the highest point is definitely in between those arrows. Enter. And 2.00000000011, that's just 2. So this is happening at the point 2, 9. Again, I label my highest and lowest points. Now I have everything that I need for this table. So increasing is where we're going uphill. That looks like over here. So the x values there are from -infinity until x equals 2. Decreasing is on the right side, so from 2 until x is positive infinity. Relative maximum, that means a point that's higher than others but not the highest. We only have one high point here and it is the highest, so in this case there's no relative maximum, but there is an absolute maximum at 2, 9. Relative minimum, we don't have any little valleys like we did over here, so there is no relative minimum. And as far as the absolute minimum, this is going to keep going on both sides to -infinity, so we also don't have an absolute minimum. Domain, remember domain is always all real numbers. Okay. Range says how far down does it go, how far up does it go. So this is going down to -infinity, and its highest y value is 9. So our range is -infinity until 9, but it will equal 9, so I'm using a bracket. Left in behavior, where is this function going as you move to the left? Well, it's going to -infinity, and as we move to the right, it's going to -infinity. So both of these is -infinity. Possible number of zeros, well, our degree is 2, so we'll have a maximum of 2 of them. And then let's go look in our table and see if we have any of the nice zeros. Ooh, look, I see 2 right there. That was nice. I have one at -1 and I have one at 5. Oh, I didn't need that parenthesis. Okay. Next, let's go graph that. X to the 4th minus x cubed minus 2x squared. I'm going to graph that. And that looks like this to me, kind of like a weird W. So just get a good sketch of this here. Something like this-ish. So we've got 2 low points here, and we've got a high point there. So let me just find those really quickly. Second trace 3, there, there. Looks like that is at negative 0.7, negative 0.4. Okay, this highest point right here, second trace 4. Oop. Oh, 1, that'll be fine. I didn't like that I did that. There we go. So that's happening at, remember, anytime you see e's, that's just 0. That's just 0, e with a negative number. So we have a relative maximum at 0, 0. And let's do one more. Second trace 3. Our minimum, there is good. Let me go. There's good. Let me go over to the right. And that's at 1.4, negative 2.8. 1.4, negative 2.8. Okay, that's basically all the steps that I need here. So increasing is where we're going uphill. I see that that's happening here, and that's happening over here. So between these two x values, 0.7 and...
Are you in the middle of something?
Yes. Okay. Sorry guys, people keep walking in. Okay, so I put this in, I found all my positions. We're going uphill in this little interval right here. So x is negative 0.7 until x is 0. And we're also going uphill this whole section right here. So from x is 1.4 until positive infinity, right? Because it's just going to keep going forever. We're decreasing here. So that's coming from negative infinity, right, on the x portion, until negative 0.7. And we're also decreasing this little piece right here from 0 to 1.4. Relative minimums. Okay, so we have two minimums here, right? Two places where this function is in its lowest value. This one is happening at negative 0.4, and this one's happening at negative 2.8. So they're both low, but this one right here is the lowest. So this is going to be your absolute. This would just be a relative one. It's lower than other things around it, but this one is the lowest. So relative minimum would be this point here, negative 0.7, negative 0.4. The absolute minimum would be 1.4, negative 2.8. Okay. Relative maximums. We have this little peak right here. So that's going to be a relative because there are points higher than that. So the relative would be 0, 0. These are going to positive infinity, so an absolute max in this situation does not exist. Domain is always all real numbers. Range, the lowest y value that it has is the negative 2.8, and it will equal negative 2.8. The highest point it's going to have is a positive infinity. So it's going all the way to positive infinity. All right, left in behavior. Looks like to me both in behaviors, it doesn't matter if you're going left or you're going right, they're both going to positive infinity. So your y value is going to infinity. Possible number of zeros, you have a possibility of 4 zeros. Let's go see how many there actually are. Quit. So I'm going to go to my table and see if I can find any. Okay, that's getting huge. Okay, so it looks like negative 1 is 1. 0 is 1. 2 is a 0. And that's good. So let's go see how many times is it touching. Now I will tell you, anytime you have a relative max or min on the x-axis, that is a root of multiplicity. So those are actually only zeros. If you need to zoom in to kind of prove to yourself that that's the case. Oh, I zoomed out. It's not what we want. Let's zoom in. We actually need to do it twice now. Here we go. Boom, bounces right off at x equals 0, goes down and crosses over here. So this right here is a root of multiplicity because it bounces right off. All right, that mess is done. Find all rational zeros of the polynomial. This is where you are either factoring or you're using long division. So here, this will be relatively easy to factor. There's only one way to multiply to 2x squared, and that is 2x and x. There's only one way to multiply to 3, and that's 1 times 3. So we need to figure out, does the 1 go here and the 3 go here, or the 3 go here and the 1 go here? I see a common mistake of a lot of people doing it this way. Okay, they're like, oh, Miss Cleveland, the outside equals 2x, and the inside equals 3x. That makes a 5x. Well, in order to do that, you have to do 2x plus 3x, so both of these end up being positive. But then right here, this positive 3 times this positive 1 does not give you a negative 3. So that does not work. Tricky. So let's try this one. Let's put the 3 over here and the 1 here. We actually need to erase those signs because we don't know if that's true. Okay, so my outside is a 6x now. And my inside is a 1x. I can still combine a 6x and a 1x to get a 5x. The 6 needs to be positive, the 1 needs to be negative to get me a 5x. The multiplication that gave me the 6x was the 2 times the 3, so this needs to be positive. The multiplication that gave me a negative 1 times an x is here, so this has to be negative. To find the zeros, we set each of these equal to 0. So 2x minus 1 equals 0. And x plus 3 equals 0. I'm going to add a 1 and then divide by 2. Over here, I'm just subtracting 3. There are my zeros. Okay, flipping on over. All right, finding my zeros here. I didn't give you a 0 to divide by, and this right here isn't going to factor by grouping. So this is where I recommended that you put this into the calculator and you look to see where your zeros are in your table. Okay, so I have one at negative 2. Oh, there you go. I have another one at, well, I see that there's one between 0 and 1, but it's not in my table. I see that there's one happening at 4, and there should only be 3, so that accounts for all of them. So you just get to pick which one you want to do long division with. I'm going to choose the negative 2. So we have 3x cubed minus 7x squared minus 22x plus 8 is divided by, remember you always change the sign, so I'm actually going to divide by x plus 2. If you need more assistance on long division, go back and watch my 12-3 notes. Okay, so what do I need to multiply x by to get to 3x cubed? That's 3x squared. Then I distribute. So 3x squared times x is 3x cubed. If you don't get the same thing here, you did something wrong. 3x squared times 2 gives you a positive 6x squared. We are going to subtract. 3x cubed minus 3x cubed, that creates a 0. Then negative 7 minus 6 gives us negative 13x squared. Drop down the 22x and then start over. That was one full cycle. So here x goes into negative 13x squared, negative 13x times, distribute. So I have negative 13x squared minus 26x. We are subtracting all of that. Right, minus a negative and minus a negative. Remember, that's going to make positives. Okay, so this is going to create a 0. And negative 22x plus 26x is going to give us 4x. Drop this down. There was 2 full cycles. Now, how many times does x go into 4x? That is 4 times. Distribute. So we have 4x plus 8. Ooh, life is good. That's what you want to have happen here if we're finding zeros. Okay, so now that we have a remainder of 0, let's go factor this. Okay, let's see here. This is kind of an easy one because the only way to multiply to a 3x squared is 3x and x. But I have a little bit of choice here. Let's stop and think about it. I can use 1 times 4 to get to a 4, right? which one is going to give me a 13? 3 times 1 or 3 times 4? 3 times 4 is going to get me closest to 13 because that'll give me a 12 and then a 1 here. So that would give me 12x. This gives me 1x. I need a negative 13, so I need both of these to be negative. Right? Negative 12x minus 1 more gives me negative 13, and a negative 1 times a negative 4 gives me a plus 4. So life is good there. I'm going to set each one of these equal to 0. I would end up adding a 1 here, and then dividing by 3. Over here, I would just add by 4. So there are 2 of my zeros, and then don't forget this one that we found in the calculator. There you go. All right, next one. I'm going to go look in the calculator here as well. So 2x cubed plus 9x squared plus 3x minus 14. The zeros I see in the calculator, let's see here, it looks like negative 2. It looks like I have another one at 1. I don't see the other one in there, so let's do some long division. 2x cubed plus 9x squared plus 3x minus 14. Let's divide that just for fun here. Let's do x minus 1. Always do opposite. So this into this, that's going to give me 2x squared. Distribute 2x cubed minus 2x squared. We're subtracting, so that's going to make a positive 11x squared. Drop down our 3. X into 11x squared is 11x. Distribute. That's 11x squared minus 11x. Subtract those. So this creates a 0. This creates a positive, so that ends up being 14x. Drop down the negative 14. X goes into 14x 14 times. Distribute. So we have 14x minus 14. Look at that. There's 0. Now we factor this. This is a nice one as well because there's only one way to multiply to 2x squared. That's 2x and x. So I could put a 1 and a 14 here or a 2 and a 7. Just thinking about my needs here to get to an 11. 2 and 7 isn't good enough to get me to a 9. I really think it needs to be this, 7 and 2. This is going to be a 14, and that's going to be 2. That doesn't look good. Let me check my work, see if I did anything wrong. Oh no, I did this wrong. Okay, here we go. 2 and 7, there we go. 2x squared, that gives me a 4x and a 7x, which is going to give me the 11x. And the 7 times the 2 gives me 14. Okay, there we go. Plus and plus. Then we can set each one equal to 0 and solve it. So if I'm solving this guy, I'm going to subtract a 7 and then divide by 2. Subtract a 2 here. And then I already have this one up here. Final answer. All right, number 7. Let's go ahead and put that into the calculator. I see x equals 1. I see x equals negative 1. And negative 3. Jackpot, they're all there. I won't do that on the actual test. Don't get excited. All right, but there's a freebie. All right, finding the intervals. All right, this is 12.5. Okay, 12.5. So first, set it equal to 0. It's already set equal to 0. Factor it. And then there's only one way to multiply to a 3, a 1 and a 3. You just need to figure out the signs. If we want a positive 2, the 3 has to be positive, this has to be negative. Let's put this on the number line. Well, here, if I added this over, this would be x equals 1. If I subtracted this over, this would be x equals -3. So -3, 1. They're open circles because of this. And then now you need to test. A lot of you have been doing it a couple different ways here. What I would do is I'd just put in my original function into my calculator, and it's going to do the values for me, right? Or you could put the factored form. A number to the left of -3 is -4. That's positive, which is not less than 0. That doesn't work. Between -3 and 1, let's see, all of these are between -3 and 1. They're all negative or less than 0. And then over here to the right of 1, 2 is positive, which is not less than 0. So my answer here is from parenthesis -3 to 1, close parenthesis, because they have open circles. All right, next one. Remember, we have to set it equal to 0 first. So x cubed plus 7x squared. I need to add 10x over. Now it's set equal to 0. Life is good. This, I haven't made you do one like this, so that must mean that I can factor out an x. So much better. So this will factor into x multiplies to 10 but adds to 7. That's a 2 and a 5. So on my actual number line, I'm putting a -5, a -2, and a 0. All right, I'm going to go put that original equation into my calculator, or I'll show you that you can do the factored form as well. X plus 2, x plus 5. Let's go to my table. I need something to the left of -5, so like -6. That's a -24. That is not greater than or equal to 0. Something between -5 and -2, like -4. It's an 8, which is greater than 0. Oh, first off, sorry, these are closed circles. So that is an answer. Between -2 and 0, that would be like -1. -4 is not greater than 0, so that doesn't work. And the number is greater than 0. Ooh, those are all positive. So that works. So my answer is this little piece right here with closed circles and all of the numbers to the right of 0. There you go. It's already set equal to 0. This factors into x and x. What multiplies to 64 but adds to a -16? That's -8 and -8. When I add these over, they're both the same number, so that makes it super easy. But remember, that's also probably one of the weird kind. It's less than or equal to 0, so we have a closed circle. This will be easy enough to do. If I have a 7, 7 minus 8 is a -1. 7 minus 8 is a -1. A negative times a negative is a positive, which is not less than 0, so that doesn't work. Over here, let's pick something to the right, like 9. 9 minus 8 is 1. 9 minus 8 is 1. 1 times 1 is not less than 0. So the only thing that works here is the 8 because it has equal to. So 8. Moving right along. First thing you have to do is set this equal to 0. So x squared plus 2x minus 8 is greater than or equal to 0. Factor this. X and x looks like 4 and 2, positive and negative. Okay, so then let's put these on. If I solve this, this is going to be a -4 and a +2. Closed circles because of the equal to bar. Go put this in my calculator really quickly. Let's see, x plus 4. X minus 2. See if I pick -5, that's positive, which is greater than 0, so that's good. Something between -4 and 2, those are all negative, which is not less than 0, which is not greater than or equal to 0. And something to the right of 2, like 3, 7 is greater than or equal to 0, so that works. Over here, this piece right here is from negative infinity until negative 4. It has a closed circle, so this is a bracket, and, or union, 2 to positive infinity. Over here, this is a difference of perfect squares. You should remember those. So the square root of 4x squared is 2x. The square root of 49 is 7. One's positive, one's negative. Oop, that said negative and wrote positive. There you go. One's negative. Solve this. If I subtract a 7 and divide by 2, that gives me x equals negative 7 halves. And over here, if I do add 7, divide by 2, that's a positive 7 halves. A lot of you have been pretty bad at converting your fractions here. Remember, if you ever need help figuring out what that decimal is, literally do 7 divided by 2. That's like 3.5. Okay, so I'm going to go put this into my calculator. 4x squared minus 49. Go to my table. So if this is like negative 3.5, negative 4 would be to the left of it, and that's 15. Is 15 greater than 0? That's yes. But it's an open circle because we don't have the equal to bar. Somewhere between negative 3.5 and 3.5, like 0, that's negative. Is a negative 49 greater than 0? No. And then something to the right of 3.5, like a positive 4. Is 15 greater than 0? Yes, with an open circle. So here we have from negative infinity until negative 7 halves with a parenthesis because it's an open circle, union 7 halves to positive infinity. Remember, anything that's on the review is fair game for the test, so please watch this, please study, and please be well.